So we're looking at the graph section that we've been given, and we're looking to do a transformation of y equals minus the function 3 times the x. So with the minus being outside there, we know that that is a reflection in the x-axis. Okay, so it's the y values that are going to be changed. So it's a reflection in the x-axis. And we also know that that 3 there means that it's a stretch scale factor 1/3 in the x direction. So when we actually do this reflection, when we complete what we've been asked to do down here, what's going to happen is that value that is the 6 here, that's going to be scaled with our stretch. So that's going to become a 2. So we'll label that one on there. And this value here, this 4, well, this is being reflected in the x-axis. So this is going to end up here and being a -4. And then we can just join those two things up really as part of our graph. And that was then good enough for our 2 marks for that first part of this question. Now for part B, I've just changed the layout slightly here, so we can then do part B. So move figure 2 here. So now we're doing y equals f of the absolute value of x. Now it's all about understanding what this absolute value thing here means. This means that if I were to put the value, say 6 in, so f of 6, well, what's going to happen? It's going to take the absolute value of 6, which is just 6, and produce and complete the function. So this value here, this 6, is going to remain unchanged. And this is the same for all the positive values of x. The function is going to do pretty much exactly the same thing as it did before. I've just made that kink a little bit too much there, so let's just change that to make that a little bit more like what that function looks like. Now, when we put in 0, well, the absolute value of 0 is just 0, so it's going to remain the same there. Now, what happens when we then put in -1? So the value here, -1. So f of -1. So the function, well, firstly, it takes the modulus of it. So it's actually going to take 1. So the modulus of -1 is 1. And then do exactly the same thing that it was doing to 1 here. In the same way, if we take the modulus of -2, it's just going to treat it exactly like it treated 2 and produce a y value. So the y value here for 1, the y value here for 2, and so on. And what we will then be able to do, if we were to plot this properly, is we would then see that it just does exactly the same thing. When f takes in the absolute value of -6, it behaves in exactly the same way it behaved with the 6 there, which was to produce 0. So we can see that we're going to get an exact reflection in the y-axis here for this second part. And we just need to make sure that we label on the -6 there in order to get all 3 marks. Now, I would advise redrawing this because, as you can see, minus doesn't look as symmetrical as it should, but what I've done is I've labelled on enough information there to get the marks. Finally, for part C, the order for these two transformations does not actually matter. We can see that we have a reflection. Now it's happening inside the function, so we know it's a reflection in the y-axis, and that's worth 2 marks. And then for the other marks, we need to make sure that we say that it is a stretch. Now the scale factor of that stretch is 2, because again it's happening inside the function, so it's the opposite to what we expect, and because it's inside, it is in the x direction. And as long as we put all 3 of these in here, we get the other 2 marks. So it's this, all of this statement here is worth the 4 marks that's given for the question.